right? By the way, there might be number of free inodes as an attribute. You know, maybe here, to make things nice and simple, you might have the number of free inodes. That would make it easier to find out, right? And then the top of the list. You know, I'm just guessing here. It depends on the way that the particular implementer implements it. So, I need a free inode. Okay, yeah, there's some left. Let me go to the top of the inode list, look for a free inode, finds it, returns that number to you after marking in the inode list that it's no longer free and decrementing the number of free inodes. So now, what do I get back?
A void.
What do I get back here? I get the inode the inode number of a free inode. Then I would record my data in one of these structures, right? And then I would use write inode to put it back. Does that make sense? You don't look like you're convinced.
Yeah, I'm not.
Okay? Inside the memory is where I'm doing all this manipulation. So at first, if I'm going to create a new file, I'd say, I need a free inode.
Right.
Okay, what's currently in that inode on the disk?
Nothing.
Nothing. So I have to get the inode number, which is all I care about. Where does it live? Because I already know there's nothing in there.
Right.
So I don't need to get nothing back. I just say 27 is where you can put stuff when you're ready to. Then I create an object of this data type, okay, in English, one of these, and I populate it.
Right.
Okay? In C, it looks like this. It's an object of this type. So I might have in my code, you know, inode. I might have struct inode, my inode. All right? What does that do?
Makes a different
There's
copy.
an object called my inode that is of type struct inode. And therefore, it's going to have what fields in it? It's kind of a field called size, a field called type, a field called terms, a field called timestamp. And so down here in my code, I might say, you know, my inode dot size equals 372. You know, then, you know, my inode, if I can spell, dot timestamp equals, maybe there's an operating system function called now. Don't know, I'm just guessing what there is. All right? And then, good. And so on and so forth, right? Now what do I need? Now that I've got the metadata populated, if I'm creating a file.
In the data blocks?
Don't I need some data blocks?
Yeah.
Okay? By the way, what if I was done with a file?
And put file back.
How about void free inode? Or release inode, let's call it. So release inode.
Release the function call?
No, release the inode itself.
The only
Puts it
thing,
back on the free list.
the only thing that confuses me is the void. If it's not
Void
getting.
means it doesn't return anything.
I understand that, but we just did put when we wouldn't get the inode, we didn't do any. We just.
I'm not saying that these are being called in order.
Okay.
I'm listing the prototypes of a rudimentary, lower level operating system set of functions that would deal with file system.
Okay.
All right? So what does this guy do?
He reads the inode.
Right? And what does it return?
Inode.
It returns a type struct inode. All right? What does this guy do?
He writes the inode.
Writes into the inode?
So to be consistent, struct inode, and I'm going to call it node. So it accepts as arguments a number of an inode and the contents of an inode. And where do you suppose it puts it?
into
on the
a,
hard drive at the X inode. It writes it out. Okay, what does this guy do?
that one goes in and tries to get us a free
It gets
inode.
a free inode number off the free inode list and updates all of the stuff. What does this guy do?
It releases the inode, puts it back
It
into
says,
the
I'm done
stack.
with this inode number, put its number back on the free list. All right? Now, if I'm building a file, someone already mentioned I've populated all my metadata. What else do I need now?
A block,
I need some blocks, right? So let's see. What kind of functions do you think we might need?
read block.
Well, let's see, how about first, to be parallel, how about struct block, read block, int x. What do you suppose that does?
It goes gets a free block.
It goes out, I give it the block number, it goes out to the hard drive, grabs all the data in that block, shoves it back to me as something called a block. Right?
Dr. Morris, can I ask you a quick question?
Yes.
With the strut, all that strut is like a file
A
cabinet.
struct is like a file cabinet. It's a record type. It's a record type, similar to a class,
Okay.
sort of, in C++. All right? Good. So then, let's see, how about this? Void write block int x struct block bk. That's my block. All right, so I need to read and write blocks. What else do I need?
You need to get a free block.
Yes, so int get free block. And I don't have to send it any arguments. I just say, give me a free block. What else might I need?
To release it once you finished.
Yes, so void release block. And I give it the block number. Now, there's a subtlety here. Okay? Blocks have more than one purpose, don't they?
Right. Yeah, because it could be either way.
Yes? So, in addition to struct block read block int x, I need to have its indirect counterpart, don't I? And what would that look like? That might be something like this: struct I block, standing for indirect block, right? Struct I block, and what it would be? Read
The
I block. Int x. Do you see it? So, and then its counterpart, void
block I block.
write I block. Int x struct, what do I call it? I block, and then I blk, something like this. All right, so those are a set of rudimentary functions that we're going to use to implement the file system. All right? So if we were creating a file, what would be the first thing that we would call of this set of this suite of available functions? Get free inode. Bam, what does that do?
Get a free inode.
It gives me a place to start my file. Then what would I do once I've got the free inode?
You would read it, wouldn't you?
I would populate all the metadata, right? Then, what's one of the important pieces of metadata? The size. That's going to tell me what?
How many blocks you need?
How many blocks I need. So given the size, I can calculate how many blocks, indirect blocks, double indirect, total that I need. Yes?
Yes.
All right? And so then, let's for this case, suppose it's a small file, and they'll all fit in the direct blocks. So let's say arbitrarily that I need 5 blocks. Okay? So what would it then do? It would call
Get it free.
it would call get free block 5 times, right? Now, maybe in a loop,
Oh,
right?
wow.
Right? And so that I'd have 5 block addresses. And so, in particular, in this little loop here, the code that does that might look something like this. So here, what's the comment here? Populate metadata. Right? Right? So let me be a little less sloppy here. Okay? So I've got a struct inode, my inode, and I've got a struct block, my block. Okay? And I'm going to make it 5. Why? Why am I making it an array?
So you're getting contagious, like contagious?
Because I've got 5 blocks in this file. Right? Now I'm hard coding it here. In practice, you would use malloc and create it on the fly. But just for a simplistic case of a 5 block. So I need an inode, I need 5 blocks. All right? Then what would I do?
A for statement?
Well, not yet. First, now that I've got the data structures of interest declared, what do I now need to do?
Go get the inodes, the
Right,
block.
so I would go, so maybe up here I've got int, my inode. What's that?
You making it your?
That's my inode number. Then I might have int my block 5. What are those?
The 5 block.
Those are my 5 block numbers. All right? So, now what? What do I do here?
Now you need to go get the inodes?
I would say my inum gets what?
Free inode.
Get free inode. All right, so what's going to happen is it's going to go to low-level routine. What's the low-level routine going to do? It's going to pull up the super block. It's going to parse this top section of it, number of inodes, number of free inodes, top of the list, inode list. It's going to find an inode number that's free for me. And it's going to update all this information and put it back on the hard drive so that that's intact. So now, free inodes is 1 less than what it used to be. Okay, top of the list has changed because I took it from the top of the list, right? And the inode list itself has now changed because it's 1 less is free. So then, what am I going to get back here? Oh, did I goof this up? No, I did not. Okay, so I now have a free inode. All right. Now what am I going to do? Remember, this is just the number that I'm going to use. Now what do I have to do to that inode?
Read it.
So how about populate
Oh, populate it.
the metadata? All right. So give me an example of how. Now remember, this my inode is the actual inode, right? And what is it? It's one of these things. Yes. All right. So what would I do to populate the inode data? I might say,
Int size.
well, no, that's just the data type, right? So I would say my inode dot size gets whatever it is, 20. Okay.
Dr. Morris, if we're using that inode, why are we making another object of the inode when we say mine? Making it mine.
This is the data type. This is the object. Just like here when I say int, that's not an object. That's a data type.
Right.
There's an int called my inode. There's a struct inode
Right.
called my inode. And so in that object of type struct inode, okay, it has a series of components. Namely, it's got a size, a char, a size, a type, permissions, a timestamp, and a whole boatload of addresses. Yes? That's what's inside the struct. This is a picture of what one would look like if I were to declare one. And so once I declare one, now one exists, called my inode. The dot notation is the way I reference the individual elements or attributes of the struct. So then I would say, my inode of size gets, well, it's obviously a 20K file. Okay, it's a 20K file, and then I would say, whatever, all the way down, and then finally, my inode dot timestamp gets, let's speculate that there's an operating system function called now. That gives me, right now, the timestamp. So now I've populated all of the metadata. Okay, now what do I need to do?
Read the metadata.
Don't I need to put some data into blocks? But before I can put data into blocks, what do I need?
Empty blocks, free
I need
blocks.
some block numbers, don't I?
Yes.
Right? So, 4. I equals 0. I less than 5. I plus plus. And what do? I'm going to say my block of I gets what?
Blocks. I block.
Get free block.
Blocks.
Look, get free block. Yes.
What is that at the bottom left? I know that timestamp.
Yeah, it equals now. Now, or time, or ahora, este momento, around.
Then why you talking?
That's all she taught me, but I'm not going to tell you. Because it makes me twitch whenever I hear those words.
I know it.
No,
Look at
She
you.
got happy then.
Man, you ready to go home? Ooh, Dr. Fox.
All right. So now what do we have? We now
Okay.
have the block numbers into which we're going to put our data, right? All right, so now presumably, somehow, we're going to put the data
Into the block.
into the blocks, okay? Now, I don't know exactly how that's going to work, okay? But let's just say, we've got another function that we're not going to discuss that does this. So populate data, and we're going to say my block, we don't care how this happens. We've got some other function that we haven't written yet that's going to take this array and this data and put it into these. We don't really care about that. Conceptually, you can see what happens, a bunch of ones and zeros. It's going to populate all 5 blocks with that data set. All right? Now what do we need to do?
Now we need to pop.
The size of the block.
Don't we need to put the addresses here? Yes? All right. Now, depending on how this was structured, if I were doing this myself, I wouldn't have discrete. I wouldn't have long A0, long A1, long A2. I would have an embedded array here. So then you could do it in a loop. Because what if you needed 10,000 blocks? Block 0 gets, block 1 gets, block 2, right? Take forever. So probably a more realistic way of doing this is to have something like this.
Long. The size of each block.
block, say, 10, right? So now, how many direct blocks does this guy hold? 10.
10.
Do you see it? And then I might have long, single indirect, long, double indirect.
And would you define a number? No?
These are just, these are, in this example, they're just discrete values. It doesn't necessarily map to what I have here.
Okay.
If I was mapping to what I had here, then this would be block 4, single indirect 2,
Yeah.
double indirect 2, no triple indirects.
Right.
Right? It's all sculptable and depends upon the nature of the particular file system implementation. It's the general idea I want you to start grasping.
Okay.
Okay? General idea. That's what I'm talking about. Okay? So then what would I do here? And I might do this. I might say for I equals 0, I less than 5, I plus plus, and then I now need to populate these blocks. Do you see it? So watch. I would say my block dot BL of I gets my block of I. Let's see if you understand what this is doing. So first of all, what's the object? I'm sorry, I said block. Let's try this again. My inode. There. Good. So what's the object my inode? It's one of these guys, right?
Okay.
Name off some of the components that it has.
Int.
It has
Size, type,
but
parameter.
does it have a BL?
Yes.
And that's an array, isn't it?
Correct.
And so therefore, my inode dot BL of I
Gets that
is
array.
the ith address
Right.
in the inode.
So you putting the information into.
And I'm taking my block of I, which has the block number, and I'm putting it into the address slot in the inode.
Right.
So now they're all written, okay? Now, where does this picture of my inode live? In memory. Where does it need to live?
And hard drive?
It needs to live on the drive, doesn't it? What else needs to live on the drive?
The
Data blocks?
The blocks as well. Agreed? So we have to now write the blocks to the drive, and we need to write the inode to the drive, and we need to update the directory. Okay? So, let's come over here. So first thing is for I equals 0, I less than 5, I plus plus. Now, what are we going to use to write the blocks?
Right.
destroy.
Okay. So we're going to say write block. Okay, write block. Now, relative to I, what's the block number?
I.
No,
Oh,
it's my block
My block.
My
of
block.
I.
My block.
It's my block of I, that's the block number. So, write into my block
the I
of I, and then where's the data?
and my block.
Where's the data?
In my block.
My block.
It's in, notice it's my BLK and my BLOCK,
Yeah.
right? They're different, right? Right, this is the first argument expects a what? An integer or a
Integer.
long, and that's what my block of I is. You see, it's an integer, okay? And then the second argument that it expects is what?
The block.
Struct block.
Struct block.
It expects a struct block. Yes? And that corresponds to, and I'm going to put it on the next line, that corresponds to my block of I. All right?
Make that last statement again.
So
You
look at
say-
the prototype of right block.
Right.
The first argument is to be an integer. The second argument is to be a what data type?
My block.
Struct block.
Right.
Okay? And so let's look at the call. Right block, what's the first argument data type to be?
The integer.
An int. And let's see if my block of I is an int. Int,
Okay.
my block 5. So the ith element of this structure, this array, rather, is indeed an int. Okay, let's look at the second one. What is my block of I? Well, my block is an array of struct blocks. And so therefore, my block of I, so what does all this do? It calls the low-level right block routine and squirts it out to the disk. All right? Now we've updated the blocks. Now what do we need to do?
Update the directory.
Well, we could update the directory. Okay? So, we haven't shown that yet, but presumably we have a directory structure in memory someplace. So for now we'll just say, update the directory. Okay? Update the directory. And then what's the last thing we need to do? Now remember, this inode here is still in memory. It's not out on the hard drive yet. So what do we need to do?
Send it to the hard drive.
We need to send it out to the hard drive. How do we do that?
Right block?
No, it's
No,
not a
we
block.
need release block.
It's not a release block either. It's an inode that's in memory. How do we send the inode contents out to the hard drive?
Copy?
Pick a function you think might do that.
Right, I know.
Write inode.
Okay.
So update the directory, however we do that. And then finally, write inode. Okay, and what are the arguments to inode, to write inode? What are the arguments to write inode?
Integer.
Right, the first one's an integer corresponding to the inode number.
I know that.
So it's gonna be int my and
My inum. So my inum, that tells it where to write it and where's the stuff to be written.
it's gonna go into the strut. I know my I know.
Yes, yes. And so just the name of it is my inode.
So you don't need the strut part, Dr.
No,
Moore?
that's only during declaration time. You only need the data type during declaration time. All right? And there it is. So we've now prototyped out a small piece of code that creates a new file. Pretty simple.
Simple when you do it.
The directory, when we update the directory.
I didn't say anything about how the directory got updated.
Yeah, but this is a question, like, why do I need, we need to update the directory that we put in the file in?
Well,
Or-
yes.
okay.
Yes, so in the directory, what pieces of information would you put in that directory?
The timestamp?
inode number.
You would put this inode number for sure.
Yes.
Okay.
And you would put the name of the file.
Yes.
Okay? The name of the file as well. All right?
You're not finished yet, though.
What time is it? We shouldn't be finished.
No, you're not finished with that.
Yeah, that's it.
Don't you got to put the I know?
Ashley, your legal friend asked a question. Would you care to answer it, Gilbert? I am so disappointed.
So sorry that you just.
Just, you know, my mama, would she get mad at me? You know, she would go, no, I'm not mad, I'm hurt. Please, please, I'd rather you get mad and beat the tar out of me rather than be hurt.
No,
No, I'm
disappointed.
just hurt. I'm disappointed.
I'm not.
Oh, please just beat me, because I can deal with getting a beating, but I can't deal with disappointing
It's
my
emotional
mom.
blackmailing.
I can see it.
It's emotional blackmailing.
Yeah, that's emotional blackmail.
Beat me.
You turn red again, so
And then when Daddy come home and beat me, then I feel good about it. This is perverted. All right, that's it. So this is a small example, incomplete, bunch of syntax errors, but a snippet of code that would create a small file.
But Dr. Morris, don't you have to put the free iNotes back?
No, because you're using it.
Because you're using
It's now recorded out on the disk. All right, so now let me erase all this. Remember everything that's here.
Oh, really?
Yes, take a snapshot.
Thank
Use that photographic memory.
you. It's burned up. Actually, I'm gonna jump off the bed.
All right? All right, so what's that?
Do you see correct?
That is one line of a directory. One line of a directory file. What does a directory file contain in it? It contains a name and an inode number, doesn't it? Yes? So now we're going to write a little snippet of code that reads a directory.
Okay.
And see what it might look like. You ready?
Mhm.